Hello everyone, welcome to this tutorial. My name is Hossein Khezri. In this tutorial, we are going to learn how we can achieve this look by using particle simulation inside Houdini and render particles with Karma XPU. One of the important things in this tutorial is slab comp. In the new version of the Houdini 20.5, we have a perfect feature which is called slab comp. By using a slab comp, we will be able to do a rough composition on our image, and it's almost real time and we can see the result in viewport. Another part that I want to talk about it is gas macrosolvers, which I used in this project. As you can see, we have a cool particles behavior. It's because of the gas macrosolvers that I used. And then for the final part, which is the debris, we will talk about the instancing process and we will see how we can optimize our instancing process. So let's dive inside Houdini and take a look. Welcome back everyone. I just want to quickly show you what I've done in this project. Then we will start to make it again from the first point. As you can see, this is our simulated particles. It's not too many particles, it's around 1.5 million particles. And let's look at the debris part. As you can see, we have a lot of pieces and it's fast. And we will see how we can make a optimized process for instancing. Then we will talk about the Solaris network. This is our Solaris network and this is our final result using slab comp. So let's make it from the first point. Now, as you can see, I have a animated camera in here. It has a simple animation, the camera approaching to the target. Also, you can make your own camera and based on that, make your scene. Okay. Let me bring down a geometry node and call it FX particles setup. I want to use a simple grid for an emitter object. Let me reduce the size to something like this and bring down a node and call it out source geo. Now we can use a pop network and link the source geo to the pop source. Great. Okay, let me turn off guide and increase the particle count to something like 500,000. And I want to add pop force. Increase amplitude to 0.5 maybe. Cool. At this point, I want to talk about divergence and pressure. As you can see, particles are following the noise pattern which is generated from pop force and they not any interaction with themselves. So I want to add something like fluid behavior to the particle velocity and calculate the pressure. We can use a useful microsolver. The name is Gas Project Non-Divergent Multigrid. It removes divergence from the velocity field and it calculates pressure for us. And if we check the help, it's also used inside the fluid solver and smoke solver. it removes the divergence by using a multigrid method. If you want to check more about the gas project non-divergent multigrid node, you can check the Thomas tutorial. He has a perfect tutorial about this only for this node. You can check that later. In order to use this calculation, we need to have a vector field, which is the velocity field. So first, I want to make a vector field and write the information, the velocity information from the particles to the vector field. Then we can use this node to calculate pressure and remove divergence from our velocity field. Then we can rewrite the information from the field to the particle velocities. So let's do the step 1. Let me add the vector field and let me call it well, and division size in here is the resolution of the vector field. I want to keep 0.1 at this point. We can increase it later. In order to visualize that, we can use the vector field visualization. Okay. Change the visualization type to speed. And don't forget to match the data name with the vector field. Both of them should be well. Now, it shows me nothing because the field is empty. We should write the information from the particle to the well field. In order to apply the information from the particles to the target field, we can use a gas particle to field. Destination field is well, and the attribute that we want to read the information and write that to the target field is the V, which is representing the particle velocity. Right, let me merge that. Let me turn off the particles. Okay, it works. It shows me the vector field. Let me increase the visualization resolution. So now the vector field, the velocity field, it has exactly same information as the particle velocity. So also we need to expand the container of the vector field matched with the particle bounding box. In order to do that, we need to use gas resize field. Let me merge these together. Okay, select the gas resize field. The field that we want to expand is the well, and the reference is the geometry, which is the particles bounding box. Now, very cool. Now we can use the gas project non-divergent multigrid node in here and merge that. Now if I play, if you check these vectors, now it calculates the pressure for us. But if I turn on the particles and see, the velocity doesn't change because we didn't apply the vector field information to the velocity part of the particles. So in order to write the information from the field to the particles, we can use gas field to particle node. This one, yeah. Source field is the well, and the attribute that we want to write the information is V. Now, if I play, it works. Cool. Let me decrease the particle number in here. If you check, it calculates the pressure and we have a cool velocity behavior. Now I can increase the division resolution. Let me set this to 0.065. It gives us more detail. Very cool. Let me add the pop drag in here and maybe I can add another pop drag. So this one gonna be a main pop drag and the second pop drag can be as a high value. One I think is good. Okay, cool. Now also I want to use gas turbulence node, which, as you know, we use this node for a smoke simulation to add the turbulence noise to the field. In order to use this node, we need to have a velocity field, which we already have, and the density field. So it needs the density to generate the turbulence pattern based on that. So we can add the density field like the vector field. But the density field is the scalar field, so we can use a scalar field in here. Change the data name to density, and I want to match the division size with the vector field. Let me copy parameter and paste relative reference. Okay, and I can use a scalar field visualization to visualize the density field. Don't forget to match the name. Okay, and use the smoke option in here. Again, if I play, it shows me nothing because the field is empty. So I can use another gas particle to field to write the information from the particle to the target field. Destination field is the density, and now I can add a density in here by using pop wrangle. Let me say f at density equal 1. Now if I play, okay, check the particle to field. Okay, this is the attribute that we want to write the information to the density field, and it's also density. Okay, great. Again, we need to expand based on the particle bounding box, so we can add the density in here as well. Great. Now we can add gas turbulence noise. Let me merge that. Change the color to red. Turn off the scalar field visualization, and now gas turbulence work. Very cool. Let me decrease the scale and size also. Okay, very cool. Now I want to use another gas microsolver, which is the gas vortex confinement. It applied the vortex behavior to the simulation and it boosts that. Let me increase the scale to 10 and merge this in here. I play. Very cool. Yeah. To reach more detail, let me decrease the turbulence scale and add the more particles. Okay, let's check the camera angle. Very cool. Let me add the pop wind as well in here. Pop wind and increase the amplitude and decrease the size, and let me add the visible roughness. Let's play. Very cool. Now I think we are ready for cache the simulation and take a play blast. Okay, let me come in here. I just want to keep the only necessary particle and delete the other ones. I want to keep velocity, age, and ID. ID in here is very important. And delete non-selected. If I check. Very cool. And now we can cache the simulation by using the file cache node. Now I have the cache and I've already run the play blast. You can check the play blast and it's cool. Now we can retime the particles and decrease the speed and choose the specific frame range. I want to use retime node and let me select frame. The 72 can be our start frame. From 72 to 144. Okay. Let me decrease the speed to 0.15 and let's play. Very cool. Okay. Let me change the interpolation to subdivision. and run the play blast again. Let me bring down a node, set out particles C. Okay, let me run another play blast. Now we can check the play blast. Very cool. So we done the particle simulation step. Okay. And let me save the project. Now we are ready for the next step, which is the debris layer. I'm going to talk about the instancing process and how we can optimize our setup for instancing. And I want to use copy to point method for instancing. There's a several way for the instancing process, such as for each loop. But in this project, I want to talk about a copy to point method. So let me give you a simple example about the copy to point method. Let me bring down a simple grid and scatter 100 points. Okay. And now let me add the torus object, sphere object, and box, for example, and merge these objects together. Okay. And now let me bring down a copy to point node. So this to the geometry and this to the points. Okay, as you can see, we have all the objects for each point. We need the random attributes based on the number of the object for each point. Now we have a 3 object, so we need the random attribute from 0 to 2. And let me add the attributes. I want to use attribute adjust integer node. Let me change the attribute name to index. Okay. And change the pattern type, the random, and decrease the max value to 2. Because we have a 3 object in here, we need a 3 random value, which is 0, 1, and 2. If we check the copy to points, we have a perfect option in here, which is the piece attribute. I want to use this option. In order to use this feature, we need to have a same index or the same name or any attribute that you want to call it from the objects, and we need the same exact information inside the particles. So we have a 3 object. Let me create the attribute for each object and let me call it index as well. Change the type to integer and change the class to primitive. I keep this 0. This is object with the value 0, and the sphere with the index 1, and the torus with the index 2. Now if we check the spreadsheet, we have an index from 0 to 2, which is great. And also we have a random index value for each point. If I want to check the attributes, I can use visualize properties and change it to the marker. Okay, as you can see, we have a random index value for each point. Now we can use the copy to point option turn on the piece attribute and change the name to index. Now we have a random object for each point. If I change the seed in here, as you can see, very cool, and it's very fast. Let me increase the grid size and increase the particle number. Very cool. It's very fast and useful. I want to use this method for a debris, so keep this way in your mind. This is an example file, and now let's start to make our debris layer. I want to use the object merge, import the particle simulation, and I want to freeze the particles at the end frame. I want to use $f end. Okay. I want to use a bound node to make a bounding box. Very cool. And I want to scatter some point into surface and also inside the bounding box. In order to use that, I can use points from volume, but I want to use a ISO offset to fill the bounding box. Change the name, city, increase the resolution, and then I scatter the 1000 points inside the bounding box. If we do not use the ISO offset, points will generate just into surface of the object. Okay. Now I want to add the attribute vector noise. Attribute noise vector, and add the noise to the position. Turn on the animation and let me decrease the speed. Okay, maybe increase the element size and reduce the amplitude. Check from the camera angle. Very good. Now we can do the same logic that we use for the instancing. In here I can use the index and the copy to point. This is a point, and now if I check, we have our torus sphere and box randomly generating to the points, and I want to control the scale, so I can use attribute adjust float or set dp scale attribute. Okay. Very cool. So they have a uniform p scale value. I want to add a random one. Again, I can use the attribute adjust float in here and change the operation from add to the multiply and the pattern type to the random. So we have a random size of the object. We add the variation for the size. Very cool. Now, instead of using the sphere box and torus object for the debris, I want to make pieces. We can start to make pieces by using the sphere. Change this to the polygon, increase that, and use a RBD material fracture. Okay, let's use the exploded view. Okay, this is good for a start. And I want to set the uniform scale for each pieces. So let me run the for each name primitive and use the match size and set scale to fit. If I check, okay. And before doing that, I also want to set the UV for the object. I can use UV unwrap for the inside of the pieces. Now if you check, the interior surface has a UV, and before we run the fracture, let me add the UV to the sphere, or I can use the sphere lab sphere generator, which is it has already UV. Then we run the material fracture and unwrap the inside group. And then if we check, let me change the spacing. Very cool. Then we can uniform the size. And now we have the pieces that we want to randomly instance into the particles. So we need the index attribute in here as well. So I want to use a connectivity node to generate for each piece attribute. Now the name is class in here, and let me change it to the primitive. If we check the spreadsheet, class start from 0 and end with the 59, so which is mean we have a 60 pieces. So you can see the name is 60. So in here, if I said the index can be 0 and 59, and let me change the class to the index as well, we can use the copy to point. Now, very cool, it works. Very fine. Okay, also we can increase the number of the debris. Okay, great. We have a debris in here. I want to add a foreground layer for debris. So let me use the freezed object in here and add a bounding box. And I want to match this bounding box and resize it with the camera. So let me come to the camera. Okay, I want to use transform from centroid node. Let me resize it. This is gonna be a foreground debris layer. Great. Again, I want to use ISO offset. Let me increase the resolution as well. This is good. Now for this layer, I want to use a pop net, and let me increase the particle count. I don't want to generate all frames. I just want to generate the several frame. I can say $SF less than 7. So after the frame 7, it not generate again. And I can add the pop force with the large scale. Let me add 5 and add the amplitude to 1. Okay. Check the camera. Very cool. Now we can use the exactly same setup that we already have in here. Let me use copy to point and copy the index and p-scale attribute for this part. And okay, we check. We have our pieces. So let me decrease the size. As you can see at the beginning, we have an issue in here because from frame 1 to 7, each frame particles are generated. So we need to use ID in here. We can select the attribute adjust integer, and actually the randomization is based on the element number, which is right now is the points number, is the PT num. So we can change this to custom attribute and use the ID. Now if I play, we have the same problem for the p-scale attribute. Let me turn off the random p-scale, and also we need to remove the velocity. So the rotation change based on the velocity. I want to just remove the velocity in here and take a look. Okay, it's worked. And now we can add the random size based on the ID again. Very cool. And we can use a time shift to add the offset, the negative offset, because we set $SF -7, so we can use a $F -7, sorry, +7. So, and run this popnet for more few frames. Now if we check, we have appropriate foreground debris layer. Now we can cache the debris layer in here. Let me use this and bring down a file cache. Now I use the original setup that I used that before, and this is exactly the same that we made it together. This is a cached debris. I just increase the debris particles, and I also add the wind and pop drag. This is a wind. Okay. And I also retime that like the main particles. And then I use the group expression to select some of the particles, not all of them, because we have the 1 point around the 1.5 million particles. So I don't want to use all of them, I want to use some of them. So I use this expression, the rand based on the ID. If it's less than this is a chance channel. So when I use the rand function, it gives me the value between 0 and 1. So if I choose, for example, if the rand ID is less than 0.5, it means the half of the particles will select it. So I want to choose 0.3. And this is, I also add the seed for that. So we have a totally control on the particles for instancing. And I just isolate that group. Okay. And then I add the PScale attribute, as you know, randomize that, and the index. I also increase the number of the pieces inside the hybrid material fracture. I set the 12 for each step of the fracture. We have a 2-step. Okay. Okay. Now we have our foreground debris and the main debris. I can merge that and take a play blast. Okay, we can check the play blast. We have the 2 layer of debris, foreground and the main one. Okay, very good. We can also play with the parameters, with the speed and the noises, or even for the pieces to get the more random value for the piece. Okay. Now we can, this is our main instance layer, and this is the foreground layer. Okay, we done the debris layer, and now we can talk about the render. Now we can start rendering process. Let me bring down another geometry node and let me call it render. I want to import the render elements. So let me use object merge to import the particles, and another one for the main debris, and another for the foreground debris layer. Okay, I want to start rendering process from the particles in here. Now let me add the null and let me call it render particles. Great. I want to copy this node and I want to use loop network and call it render stage. This is my workflow. Now you can dive inside. This is a Solaris network, and it's very easy to use for the render. I can use a sub import. Okay. And paste. Let me link that to render and render particles. So we have our particles, and if we quickly run the render, we have our particles, but we need to set the p-scale attribute for render, and I also want to add the alpha attribute to the particles. So pin this viewport, go to the render in here. Now run the CarmaX view. I want to add the attribute adjust float to set the p-scale value. Let me set 0.03, and it's big. Let me reduce the size. Okay. Also, I want to change the background color to dark gray. Very cool. Now I need to import the camera to the Solaris stage. So go to the Solaris stage, and we can use the scene import camera node. Okay, if I check, I have a camera. Let me restart the render. Very cool. Also, let me add the very basic light using the doom light. Okay, I think the size is okay. Now let me add the another attribute adjust float to use a ramp based on the age and multiply it with the scale with the p-scale attribute. So I want to change the operation from add to multiply and use the remap attribute, and I want to use the age attribute. So yeah. Okay. Very cool. I also want to have a random value for p-scale based on the ID, so I can use another attribute adjust float. Again, change the operation to multiply and use the random, and I use the custom attribute, and it's the ID. Let me change this, the minimum value 0.25, and it gives me a random p-scale value based on the ID. We go through. Very cool. Now I want to add the color. I can use attribute adjust color node, and I want to use a remap. I want to use a random again. Use the random pattern type and change this to the ID again. And if you check, it randomly add the color ramp from here to the particles. But I want to use maybe 3 different color. Let me say use this color, orange, and the yellow one. And in the middle, I can just add. So per each ID attribute, per each point, based on the ID attribute, we have these three color. Very cool. Now if we go through the particles, we have a random color as well, and we have a random scale and random color right now. And now we can assign the material to the particles. So go back to the render stage and let me bring down a material library. So I don't want to simply merge this into here. I want to use a reference node. This is a workflow for the USD that I use that. And I want to use a reference node to merge these together. And go to the multi-input. Let me switch to the Solaris workstage. Go back. Okay. Now, in the sub import, we imported our particles. I can call it FX particles. And this is a scene graph path. I like to use this path prefix $OS. So I have a group in here. I like to use this hierarchy for the Solaris network. So I have a main group, which is the FX particles, and inside that I have a component, again, is the FX particles. And then I use the reference node to add the material inside the material library to our hierarchy. I can change this to up input. To read the input name of the object and slash materials. Let me dive inside and use the Karma material builder. Let me call it FX particles mat. And now, by using this method, I have a FX particles, which is the group. Then I have a component, which is our original particles. And then I have a material in here. And inside the material group, I have a shader, FX particle mat. So I always use this method for importing and assign the material to the object inside the Solaris. I already make a recipe about that, KZ lab import, so it's import like that. I need to assign the object. Okay, now I can use a assign material node inside the Solaris. Select the object into primitives and add the material to the material path. Now, if I render, and let me change the light. Let me set the red color to the material and it's work. But as you can see, we lose our original particle color that we set that in the sub level. In order to read the value, any attributes or even color inside the material X, we can use geometry value, but in this case we have a color, so in material X we already have a MTLX geometry color, so this automatically read the color. We can assign this to the base color. Great. So again, we import the objects, particles, and we made the material library and make the material X, and we assign that, and then we read the color attributes. Okay, very cool. Now let's check from the camera angle. So as you can see, if I use the light, and let me add a simple HDRI, something like this, our particles is rendered as a sphere and they have a shadow, but in this project the particles should be as a light source and they not have a shadow, and they should be a emission object. So I don't want to use the MTLX standard surface. I want to use the onlit MTLX surface. Onlit. And I can set the MTLX color to the emission color and add output to the surface. Now, if we check, we can see the shadow for the particles. Okay. The trick in here is to increase the emission amount and decrease the opacity. Maybe something like this, and add a little bit transmission. Let me set emission to 12. Now it's going to be good shape. Let me decrease the emission amount. Now, because we are in the render step, so you can select this one and turn on the correction toolbar and change this to the ACES 1. I want to use OCIO, and this is the ACES 1 SDR video. Now, let me just increase a little bit opacity, maybe more. Now we can see some highlights and inside the particles, which is good. Let me back to the render sub and change the color. I want to increase the saturation. And change the color. Yes. Yeah, it is cool. We can also play with the p-scale attributes. Let me increase it a little bit. No, the previous one was better. Let me just add this value. Okay, go back to the render stage. And now I want to add the motion blur and apply some settings. I can use a render geometry setting and assign this to the primitive should be the fixed particles. And I can come in here and set or create velocity blur. Now we can see the motion blur, which is very cool. And I want to go down and find the light parameter. I want to set this is the light source and increase this. This parameter useful when we have the other object that makes the particles as a lights and they affect to the other objects. Okay, this is cool. Let me go inside. Very cool. Now let me bring down a null and call it out fx particles. Okay, now we can import the debris layer as well. So if you remember, we have a 2 layer of debris. One is the foreground and the second is the main debris layer. So I can copy this setup. Let me call it debris, the main debris. And let me come to the render stop in here. And now this is the foreground debris and this is the main debris. Let me bring down a null and call it render main debris. Okay, copy the node to paste that in here. Now we have our debris. Very cool. So actually we need the texture for the pieces. We already have a UV attribute for that, so we don't need to worry about that. So I just want to make a very simple texture for base color and for the normal. I can come to the debris setup. I want to use cup network, and this is a new cup network inside Houdini 20.5, which is very useful. I can use a noise. This is a noise. Let's change the offsets, increase the amplitude, add the roughness a little bit. Okay, let me use mono to RGB. This is gonna be our base color. Okay, let me bring down a null and call it out base color. Okay, and I want to use height to normal. Okay, and again this is gonna be our normal. This is very simple setup. Okay, let me copy the base color and let me check this in the sub level as well. This is our pieces. Use the exploded view. Okay, let me use quick UV quick shade and let me paste the path of the base color, and we need to use the up operation like this, up and then the whole path. So we have our texture which is correctly applied to the piece object. I think it's not bad because it's not really visible, and this is enough for this project. If I come to here and change the element size, as you can see how it's worked, and it's very perfect. Let me set this something like that. Okay, again I want to copy this one and back to the render stage. This is our debris, and let me come in here, delete this one and make another karma material builder. Let me call it FX main debris matte. Go inside and we can use the image MTLX image and paste the path of the texture in here, which we made that with the cop network. And don't forget to use the up operation because it needs to read from the disk, from the files. So by using the up operation we can read inside the Houdini. So now I can assign this to the base color. Go back and select the main debris to the primitive and the material as well. Great, as you can see we assigned the material with the texture that we made to the debris layer. Now we can go and change the specular to 0.7, maybe decrease the index of reflection IOR to 1.3, I think. It's good. Let me merge this with the original particle and check with the camera. And let me turn on the doom lights, decrease the intensity. As you can see, the particles, it's like the light source and they affecting to the debris in these areas. As you can see, we can control it in here. Okay, let me increase the very cool. Now we can add the second debris layer, which is the foreground. I just want to copy the whole setup in here. Let me call it FX FG debris. And let's check the render sub. Let me bring down a null and call the foreground debris to render FG debris. Okay. Now we can select it in here. It take a while actually. So we have our foreground debris layer. Now we can assign the material into it. So I need to mention one important thing, because let me back to the debris setup, that the copy to point setup. I used the pack an instance option to pack the objects pieces to make it fast. As you can see, we have a pack primitives. I use this one. So I want to keep the pack object and use the instance option inside the Solaris network to optimize my scene inside the Solaris. So I can come to this option. Let me select the sub import node. Go to primitive definition. And let me turn the pack primitives on. And instead using the create native instances, we can switch that to point instancer. Now they become the point instancer. If we check the scene graph, otherwise they are like the pack primitive and make our scene heavy, because the Solaris to applying the shader or the read the value, it can be used. We can use the point instancer setup. As you can see, they are the native instance object, but I want to check this on and use the point instancer option in here. Great. I want to do the same thing for the main debris. Turn on the pack primitive option and switch that to the create point instancer. Very good. Now let me assign the material as well for the foreground debris. Now we have the foreground debris with the material, and I can merge that to the whole scene. Let's take a render. Very cool. Now we've imported all the FX layer. Now we can go to slab comp and add more lights and render var and set the render setting. Now I want to talk about one of the perfect feature in this version of the Houdini, which is the slab comp. And let's use the slab comp in our project. Let me bring down a comp network, go inside, and let's use slab comp block. Let me change the color. Now, as you can see, slab comp import the render, and inside the loop, inside the block actually, we can add some effects like glow, let's put the display flag into block end. We can go to composite view, and don't forget to switch this to the SS1 SDR video. And now we can composite our render in here, and also we can check it in the viewport. First, I want to add a bright node in here and decrease the brightness. Then I like to add a gamma. Okay, and decrease the value. Very perfect. And now I want to add the difference setting glow. Now I just want to add the big one, the low brightness, add the another glow with the small size, decrease the glow threshold and also the brightness. I want to add another glow for the mid-range, also another glow, increase the size again. Let me increase the gamma in here. Very cool. And let me use another gamma in here. Now I want to select the highlights range and add again into the render. So let me back to here and let me add the bright node. This is the bright node. Let me increase the brightness and decrease the shift. Yeah. and I want to make it white, so I can make a saturation 0. Let me add the blur as well after that. Very less, even more. Okay. Now I'd like to set the color again. We can use the bright node and change the tint to something like this. Now I can use the add, and BG is this layer, and we want to add the highlights to the main. Because we have an alpha in here, I don't want to merge alpha, so I can turn this. Let me come to here. This is the alpha. I want to remove alpha. We don't want to have alpha for this channel. Let me use RGBA to RGB, and I want to add only the RGB to this layer. And before that, I want to use a clamp node. I don't want to see a negative value. Now it's okay, then it's work. Okay, we can boost the highlights by changing the mask scale. Okay. Let me add a little bit glow to this layer. Okay. Very cool. Now we can control our highlight range. And let me add another glow with a very big size and very less amount. Perfect. Now this is very interesting. Now we can check the slab comp also in the viewport. Go to the render, and in Houdini 20.5 we have this control option in here, which is the control slab comp setting. If I press that on, as you can see, we have the slab comp applied to the render. Now if I go to with the another side, it works, and it's very perfect picture. This is the previous render. We add the different layer of glow. Okay. Perfect. Now I want to add the camera render setting. So set the final render setting, choose the camera, and I want to use the XPU parameters and increase the diffuse limit to 3. Let me turn off the depth of field at this point, and let's take a look. Actually, I use the 2K with the cinematic scope, and I want to use 2048 resolution by 871. This is my aspect ratio and image size. Okay, it's very cool. We can check it with the another frame. Let's go to the first frame. Yeah. As you can see in 2K resolution, the XPU is very fast. It's less than 2 minutes with my config. So another things, if you check our setup from the top view, as you can see, we still see the grid shape because of the source grid. So I really like this and I want to keep this, because when we check the particles in the camera angle, it gives us a highlight from the left to right. It's because of the grip shape. As you can see, we have a perfect highlight from the left to right. Also, we can remove that based on the age attribute, but I want to keep this. Yeah, it's very cool. Now at the end part, I want to organize my scene. Let me add merge, and I already added 2 lights. Okay, and one is the doom lights without any HDRI texture, with a very less intensity, and the sphere lights, which I added in here. I use this light for the foreground debris. Let me start render. Yeah. Okay. Now I want to set some AOVs, and also I want to make a slap comp into the different AOVs. Let me add additional render bars. Let me set, this is gonna be beauty, and let me set the name to CC. Maybe the name is the CC, and I'm going to copynet slap comp, and I want to only use the CC AOV. Let me delete the depth, set this to here, and also for the block begin and block end. Okay, let's check the AOV. Turn on the slap comp, and I have a C, which is the beauty pass, and I want to switch to the CC, which is the slap comp. Very cool. Now when we export the render as a EXR sequence, we have two different AOV, which is one of them is the main beauty pass, and the second is the CC or the slap comp result. If you want to composite the final output with the nuke or the fusion, you can use the C layer, the original render, or maybe the slap comp result. You can choose what you want to do with the AOVs, but I like to have the AOV with the different name. Go to composite view, again change this to the aces 1. Okay, very cool. Also I added some another nodes. Let me show you. I use the edge detect to detect some edges of the render. Then I change the bright and reduce the shift. Then I use the clamp to clamp the value between 0 and 1. I don't want to have a negative value. Then I just add the glue and I just remap the range, and I use the quantize, as you can see. Then I use the clamp again, and for the final I add color to that, and then we can add this into render. Let's check. Very cool. Let's give us the cool shape. We can reduce the size. Let me something like that. Okay, we have the interesting shape. We check this one, before, after. Before and after. Let me use this like this. And also I want to blur, I want to keep focus on the center and blur the other sides. So I can use a STF shape. This is a STF shape, and order, I don't have a radial in here, so I want to use STF2 mono, and then I want to use size ref. This is okay, this is a size ref, and we can add this for here. Now let me reduce the size. Okay. And now I can add the blur to blur the mask. Maybe this one is good. And I want to use a bright. Okay. And I want to use a clamp to make sure this mask is between 0 and 1. And now we can add the blur node at the end of the render. Let me increase that. And we can use this mask. Then we can invert the mask. So let's check. As you can see, this area is blurred. So let me change some few parameters. Let me change the mask size. Great. Let me decrease the blur size. And I use this mask also for make a center brighter than the other side. And decrease the other side brightness. Now we can check. This is before and this is after slab comp. You can add your own color correction and effects such as glow or the different amount of the edge detection. Then you can add on the front layer. Now I think this one is good. We can add the final HSV adjust. Let me increase a little bit saturation and change the hue shift. Even you can definitely change the whole color. It's very cool. Now I think this one is good. Or 3. Decrease the value and use a shift. Very cool. Go back to the Solaris stage and check the slab comp. In here is work. Now I think we done and complete all the parts, and you are now be able ready to render your image. And if you want to do advanced composition using a Nuke or the Fusion software, I recommend you to use a deep output to extract the depth information of your scene, and use the depth information from your deep file, and then you can add the ZD focus if you're using Nuke to make a perfect blur, foreground, and depth of field in your render. So I hope you enjoyed this tutorial and you learned something new. Thanks for watching. See you soon.